Example 3b, we want to divide negative 2x plus 4x cubed plus 18 plus x to the fourth divided by x plus 2. Okay, so, and we're going to use synthetic division. So first thing, okay, if we weren't given this directions to use synthetic division, what you first want to do is you want to look at your divisor and make sure it is in the form of x minus c. In this case it is, because we can write x plus 2 as x minus a negative 2. Right? So that just means our c is equal to negative 2. Now what we want to do is we want to make sure that our dividend and our divisor are both in descending order. So my first term, I have x to the fourth. So since my degree is 4, I know I need 5 terms. I count 1, 2, 3, 4. I only have 4 terms. So I know I'm going to need a placeholder somewhere. So I'm going to be on the lookout. And then I don't have an x squared, so this is going to be 0x squared minus 2x plus 18. Okay, divided by x plus 2. Now I'm going to set up the synthetic division. So my c, okay, remember this is x minus c, so my c in this case is negative 2. And I'm going to put it in a box. And then I'm going to write all the coefficients. So remember, when there's no number here, it's just a 1. Then I have 4, 0, negative 2, and 18. And then that horizontal line. First steps, always bring this down. Always an arrow. So this is 1, and then I'm going to multiply this by c, which is negative 2, so I get negative 2. We're going to add, so this becomes 2, negative 4, and this adding becomes, this is negative 4. Negative 4 times negative 2 is positive 8. So when I add these two, I get 6. 6 times negative 2, that is negative 12. And when I add, this is 6. Okay, remember this is always the remainder. So maybe I should put in a different color just to show I don't, you don't need to write that, okay? This is just for your own thing. This is the remainder. And I always put a box here just to show. So again, to reiterate, you can either start the remainder, and then this is going to be your 1's, x squared, and x cubed. But if you don't want to go from right to left, that's perfectly fine. All you have to do is you have to take this leading term, and I know my n is 4, so then I know that this is going to have to start with n minus 1, so this has to be an x cubed. Okay, either way, as long as you get to the correct answer, it does not matter. Okay, so x to the fourth plus 4x cubed minus 2x. Don't need to write the plus 0x squared because that simplifies to be nothing. Okay. And remember, it is your quotient. So my quotient in this case is just x cubed plus 2x squared minus 4x plus 6. And then my remainder is 6, so this is 6 over x plus 2. Okay. And that's my final answer. I do want to talk about example 4 and 5 really quickly because I realized, especially for the 1030 class, one, I didn't use the factor theorem, and two, put in a lot more work than what we actually needed to. So let me quickly do example 4 and 5. So example 4, again, we want to do a quadratic equation. What does it mean to be a quadratic equation? It just means your degree is equal to 2. Okay, remember, quadratic equation is a special case of a polynomial function. Okay, but what is a quadratic? So a quadratic equation is different from a quadratic function. A quadratic equation, this is going to equal 0. A quadratic function, okay, so you gotta be really careful when you see function, is that it's just f of x, and then is equal to ax squared plus bx plus c. Okay, so function, you let it equal, have this guy. An equation is when it equals 0. All right, so we know roots are 2 and negative 3. I'll just put negative 3 and 2 since I was already writing that. And leading coefficient of 3. Okay. So I did show you guys like x equals negative 3, x equals 2. Then I use the zero product property backwards. However, what's the point of telling you about a theorem if we didn't use it? So let's use it now. So since I know negative 3 and 2 are roots, we're using the first part of the theorem. So we know that f of negative 3 is equal to 0, and we know f of 2 is equal to 0. So what does this imply? This implies that x plus 3 is a factor. Okay. And then this implies that x minus 2 is a factor. Okay? So, yeah. So we know that, and then we know that the leading coefficient is 3. So, I guess you can say by factor theorem, or I guess, okay, sorry. This is by factor theorem. Okay, so this tells us 3 times x plus 3, x minus 2. And because it's an equation, just equals 0. Okay, and again, this is my final answer. A good way to check is because we want a quadratic equation, which means degree 2. My degree is 2, that's good, and we want the leading coefficient to be 3. And so the leading coefficient, remember, is the coefficient of your leading term, and it's also 3. Okay, so not as much work as before. So now let's do example 5. Okay, example 5, we want to find a polynomial f of x of degree 5. So find f of x. My degree, or I'm going to denote it by n, is 5, and it has the following zeros. Okay. So again, by factor theorem, okay, we know f of 0 is equal to 0. Then this implies x minus 0, which is equal to x, is a factor of f of x. Okay. F of negative 4 is equal to 0. This implies that x plus 4 is a factor of x. Okay, but it's also multiplicity 2. Okay, so that means this. Okay, f of 2 is equal to 0. So then x plus 2 is a factor of f of x, and then f of negative 9 is equal to 0, which implies x, this minus is a factor of f of x. Okay, so my final answer, I have f of x, and I know all of my factors. It is x plus 4, okay, squared because it's multiplicity 2. This is x minus 2, and this is x plus 9.